Here at the Center for Infrastructure, Energy, and Space Testing, we are addressing critical infrastructure and aging and deteriorating systems.
Repairs Testing and Analysis team consists of 4 institutions, the University of Colorado Boulder and Cornell University, who will be conducting external load testing, GTI Energy, who will be conducting internal load testing and material testing, and the University of Southern Queensland, who are conducting the numerical modeling and finite element analysis.
Aging pipe infrastructure is a problem that Repair is trying to address. Our testing and analysis validates 50-year design life cycles of new technologies that we want to bring to market.
CIEST is leading the project from a managerial perspective, and we are also running external load testing on the various repair technologies.
The testing at CIEST is performed on axial and bending test frames equipped with high-speed dynamic actuators.
The intention is to assess and validate the technologies to ensure that anything that is put into the ground has an appropriate level of longevity over a time that is going to be valuable to our utility partners and the industry as a whole. The external test will include a series of experimental procedures that starts with traffic loading or vibrational loading, which includes 500,000 cycles of load applied in the lateral bending in one of our 2 lateral bending frames. These deformations will be representative of a shallow buried pipe underneath a roadway and mimic the types of deformation that you would see from very large vehicular loading. Once we get through 500,000 cycles of traffic loading, we move to parallel excavation or undermining effects, which is a larger lateral bending load on the order of several degrees of rotation that the specimens are going to need to be able to accommodate at the repair itself and not with the host pipe. The undermining load will be applied, and then we'll follow that up with another 50 or 100,000 cycles of traffic loading before we go to the axial testing frame. The axial test frames, we will be applying axial loading representative of temperature effects from seasonal temperature changes where we have elongation along long sections of pipe that are concentrated in localized areas, and simulating the worst case effects of this temperature or axial deformation. The last series of tests will be an axial pull to failure. The intention of the axial pull to failure is to address the bond strength of the PIP or repair within the host pipe under the most severe loading condition.
We have aging infrastructure. We are investing in identifying and pushing forward technologies that can rehabilitate it, and that is something that we're doing here at CIEST.